Hello, and in this video, I would like to show you how to use two programs, two websites on the internet to easily do a very complex task of taking an entire community survey and then creating a phylogeny for it. So we're going to use the iNaturalist website to access the full community, that is everything that lives or that's been observed in one location, and then take that data and quickly make a phylogeny for the entire community, no matter how big it is. So let's get started. I'm going to share my screen with you. And then, not that, obviously. We're going to go right to the iNaturalist website. So I'm going to show you how to capture community data. All right, so let's say you're doing your ecological project where you're looking at a gradient. And I've asked you to get species or community data for several different locations comprising different locations along a gradient. Let's say you picked, I don't know, elevation, so from high to low. So I'm going to go into, I'm in observations in iNaturalist, and I can go to location, and I'm going to type the top of a mountain. How about Mount Baldy? Nice local mountain. And now I've sorted the observations to everything found on Mount Baldy. I'm going to go to filters because I want to make this a little clearer. I'm going to get only research grade material. Okay, so I'm going to update my search for that. And now I have everything that's research grade material. Now, that's it. I've captured that. So let's look over here real quick at that. It's 49 observations, 82 different species. So this is the community that I'm interested in. From this, in our larger assignments, when it comes to the synthesis papers, I'm going to ask you to make a ecological network connecting all of these species in some sort of interactions, and a phylogeny. And that seems a little daunting. So let's take the next step. We're going to go up to filters, and I'm going to hit the download button. However, it's going to ask me for, to specify what exactly do I want to download. So, this is all the general stuff. I've already sorted it by, the general things that I want. I want to make sure that they're professional grade things and it has a little preview there, but I'm going to choose columns. Now this is going to be columns in a spreadsheet that this is going to download to. So I don't want a lot of columns. I don't like it too cluttered. So I'm going to say, I just want, let's see, out of this data set, gosh, I don't even know. I mean, if I wanted capture or cultivated, this would be if I was assessing native and non-native. If I wanted to do time and date, if I was interested in seasons, I would select that. But I don't really need anything from this column. The geographic data, I'm going to click none, and then go back and put the latitude, longitude, just so I can keep track of these things a little better. I could, pick, place names or something to keep track of it, but I like the latitude and longitude just the way I think, I guess. Then taxon extras, I'm going to select kingdom, class. I want the phylum. I would like the species name. I want the family, the order, and maybe the genus. Okay, looking through it. That seems like it'll do. You can select more if you like. This will make my data set easy to sort by major groups later. Okay, so then I'm ready. I just hit create export. Here it comes. If it's giant, if you have like 10,000, then you might get this later in an email. But this is a kind of a small list, so it's ready to download. I hit the download button. Here we go. Downloading to the zip. There it is. Boink. I click on it. Observations. There it comes. Okay, so there we go. That's now. It turns out it opened in sheets for me. There's all the info that I wanted. It's not a giant data set. So now I'm going to highlight this whole thing. Boink. Yeah, please give me everything. And then I'm going to copy it and I'm going to, because I work in Excel, so I'm going to open Excel, and I'm going to paste this stuff into Excel. Pasting, I assume. Pasting, I assume. Yeah, okay. Now it's all in Excel. So there's all the data that I asked for, all in Excel. I'm going to, I can now sort it by the taxonomic items, if I like. Or I can sort it by anything, maybe just by phylum, maybe just by species. But anyhow, I'm going to show you what it looks like next, because it's kind of tedious to go through these little different steps. So I did the same thing for Mount Wilson. So here's the raw data. It looks just like the stuff we just got from, but this is from Mount Wilson. And then I sorted by taxa. And I suppose I can show you what that looks like. So let's go back to our Mount Baldy data. All right, I'll highlight the whole works. And in case you're not familiar with this, you go up to data, and sort. And I'm going to sort by, I'd like to put the kingdom first, right? And then I can click the next category, sort by kingdom, then by, sing along if you know the tune, phylum, then by, what comes next? Kingdom, phylum, class, right? So where's my class? Class, name, then class, after class comes order. Well, see, there is a reason to memorize this stuff. Order, family, wink, and then comes genus, and then comes all subspecies. Perfect. And then I hit OK, and now it's sorted, right? So now everything in this data set is sorted first by kingdom. So if I want to know all the animals, then if I want to know all the phylum Arthropoda is there, and then class Insecta, etc. So that's what I did here to get this data set for Mount Wilson. And then I highlighted just the species, and I cut that and put it in another sheet, which I then got rid of all the duplicates and counted how many. Because if you note over here, let's just pick a species, Ceanothus leucodermis, for example, many individuals there. So what I did was I counted how many, like say 6, and then I put the number in the column next to it, and basically deleted those that were duplicates. But I kept the number of how many there were. So I end up with a data set that tells me the species, a simple list of species here, how many of each there were. Then I can use that to calculate, this is first the proportion, and the proportion, by the way, is the number of that species divided by the total. There were 291 observations of 111 species. So 291 altogether observations made, and there were 111 species. By doing this proportion, where I divided the number for each species by the total, I begin the calculation for calculating species diversity using H prime. Then I take the natural log in the next column, and then I multiply the proportion times its natural log, and then I sum that, and I've had this calculate the H prime, the Shannon-Weiner diversity index, 4.1 or 4.26. So there, I've made good use of this spreadsheet really quickly. But now let's do something really crazy. What we would do is we'd highlight this column, the column of species, and we're going to do this. I'm going to copy this, and then I'm going to open Word. I'm slow, by the way, so I do this stuff kind of old-fashioned way. Open a new document. Do. What do you do? Okay. Whatever. Anyways, I'm going to paste the species list in here to this Word document. And then when I go up here to save it, I want to save it as a text file. Check this out. So save it as, I'm going to save this as Mount Wilson Diversity. And I'm going to save it as a text file. Plain text .txt. Boom, do that. Okay. Okay, it's going to do whatever. Perfect. Thank you very much. Okay. Now, close this. Now, we're going to go now to another website. Here's where we're going to take that entire community and turn it into a phylogeny. So on the Time Tree website, timetree.org, you can go down and it says, hey, you want to load a list of species? We'll make you a phylogeny. So I choose the file. Has to be a text file, turns out. So I'm going to look for my Mount Wilson Diversity TXT file. There it goes. I think this is it. Let's see how it goes. I upload it. Ooh, how exciting. There it is. So this is the list of species that I just loaded. I just put this in there, 111 species. And it generated for me an entire phylogeny. How all of those are related. And then, if you'll notice kind of down here, these colored bands represent time periods for divergences. So for example, this whole group, which are the conifers, by the way, in this group, all diverged right here at the beginning. I mean, the first two groups diverged at the end of the Paleozoic and then diversified in the Mesozoic. That's awesome. Now, here's the other cool part. If I scroll down even further, this is a list of the different events that were kind of happening on the planet at these different time periods. These are Earth impacts, which would be like asteroid impacts on the planet. Pretty awesome when they happened. You can see if any of these divergences correlated with those. This is the oxygen level in the atmosphere that you can correlate and see if divergences happen at different oxygen levels. Carbon dioxide levels, same sort of thing. The overall solar luminosity just increases over time, but that's just because the sun's expanding on its way to eat us. Anyhow, so that's all pretty cool. You can correlate events on the planet with divergence times in this entire community and see that these evolutionary processes that led to this community composition took a very long time, and many different evolutionary mechanisms would be present in this. For example, if I go back to the Proterozoic and I have a divergence of two major groups in the Proterozoic, then you think about what sort of evolutionary mechanisms are happening. Because kind of during especially the Mesoproterozoic period at about 1.2 billion years ago, this is the critical time period for endosymbiosis as a evolutionary mechanism to take place and cause these divergences of major groups that might be like kingdom level divergences. So you can actually start to think about the evolutionary mechanisms as they relate to these different things. Now I can quickly download this as an image file, right, to incorporate it into my reports and other things. I click on this, look at that. There it is, easily accessible. Now, if I did this for another community, I could put the two side by side and make some direct comparisons. This is super powerful. I don't know if you're very impressed with this, but it blows me away that in this very short time that we could do such a powerful analysis. So there you go. I'm going to stop sharing my screen. And I hope you found that useful. And so that's how you go about starting with your community, going all the way to phylogeny and starting to interpret the evolutionary mechanisms taking place. So very cool, right? Yeah, I hope to see you later in some more exciting videos.